Hello everyone, I hope you're doing well today. Today we are going to learn how to solve simple radical equations. We are going to do this using 3 simple steps. Step 1 is to isolate the radical expression or expressions and square both sides of the equation to eliminate the radicals. Step 2 is to solve the resulting equation using an appropriate method. And step 3 is to check for extraneous solutions. When you solve a radical equation, you may get to the end and have more than one solution, and when you check them, you may find that one or none of the solutions work. Let's try looking at an example together. X minus 6 equals the square root of the quantity of negative x plus 8. If I look at my right-hand side of the equation, the only thing over there is the radical. So the first part of step 1 is done. And I just need to square both sides of my equation to eliminate the radical. Remember the square root symbol, the radical, and the exponent 2 will cancel each other out. So I'm left with the quantity of x minus 6 squared, which means I'm multiplying it by itself, equals negative x plus 8. When I use the double distributive property to simplify the left-hand side of my equation, I end up with x squared minus 12x plus 36 equals negative x plus 8. I notice I'm left with a quadratic equation because my highest degree is 2, which means I need to set my equation equal to 0 and factor it using the zero product and solve it using the zero product property. So I'm going to add x and subtract 8 from both sides of my equation, and I'm left with x squared minus 11x plus 28 equals 0. Factoring this quadratic trinomial using the diamond method, I would be looking for factors of 28 that sum to negative 11. That would be negative 7 and negative 4. So my polynomial factors into x minus 7, the quantity of x minus 7, times the quantity of x minus 4. And I know it's equal to 0. Using the zero product property and setting both factors equal to 0, I get that x equals 7 and x equals 4. However, at this point, I am not done solving this equation yet. I have 2 possible answers. I need to plug them both in and check to see if I have any extraneous solutions. So let's start off by plugging in our first value for 7 for x. 7 minus 6 equals the square root of the quantity of negative 7 plus 8. 7 minus 6 is 1 equals the square root. Negative 7 plus 8 is 1. The square root of 1 is 1, so I get 1 equals 1. That checks out. So 7 is a solution. Now let's check our other solution of 4. When I plug 4 into my equation, I end up getting 4 minus 6 is equal to the square root of the quantity of negative 4 plus 8. Simplifying both sides of my equation, I get 2 is equal to the square root of 4, negative 2, sorry. When I take the square root of 4, I get 2. I get negative 2 equals 2. That is not a true equation, which means that 4 is an extraneous solution. So the only solution to our equation is 7. Please take a moment to pause this video and record this example in your notes. Let's try taking a look at another example. So I have the equation negative 2 times the square root of the quantity of 48 minus 6x minus 16 equals negative 2x. For my first step, I need to isolate the radical expression. That has not been done here, so I'm going to start off by adding 16 to both sides of my equation. But the radical is still not isolated because I am multiplying it by -2. So I need to also divide my equation by -2. So I get the square root of the quantity of 48 minus 6x equals x minus 8. The second part of step 1 is to square both sides of the equation to eliminate the radical. So my left-hand side of my equation becomes 48 minus 6x. And using the double distributive property to multiply the quantity of x minus 8 by itself, I get x squared minus 16x plus 64. Now again, I notice I have a quadratic equation because my highest exponent is 2. So I need to solve this equation using factoring and the zero product property. So I'm going to subtract 48 and add 6x to both sides. So my equation becomes 0 equals x squared minus 10x plus 16. I would factor the expression x squared minus 10x plus 16 using the diamond method. When I factor that, I'd be looking for factors of 16 that sum to -10. That would be -8 and -2. So it factors into the expression of x minus 8 times the quantity of x minus 2. And I know my equation is equal to 0. Using the zero product property, I set the factor x minus 8 equal to 0 and x minus 2 equal to 0. And I get that x is equal to 8 and x is equal to 2. Now my final step is to plug in both 8 and 2 for x to check to make sure there are no extraneous solutions. So let's start off by plugging in 8. Okay, so I'm going to start off by simplifying the left-hand side of my equation. I'm going to start underneath the radical doing the multiplication. 6 times 8 is 48. I'm going to continue simplifying underneath the radical, and 48 minus 48 is 0. The square root of 0 is 0. So -2 times 0 is 0, and 0 minus 16 is -16. When I simplify the right-hand side of my equation, -2 times -8 is -16. So we get -16 equals -16. That checks out, and I can confirm that 8 is a solution. Now I also need to check my solution of 2. So I'm going to plug in 2 for x. Simplifying the left-hand side of the equation, I would start with the multiplication under the radical. 6 times 2 is 12. Continuing simplifying underneath the radical, 48 minus 12 is 36. The square root of 36 is 6, and when I multiply -2 by 6, I get -12. -12 minus 16 is -28. Simplifying the right-hand side of the equation, -2 times 2 is -4. -28 is not equal to -4, therefore 2 is an extraneous solution, and the only solution to our equation is 8. Please take a moment to pause this video and record this example in your notes. I'd like to look at one final example before we wrap up our notes today. So we're going to look at the equation. The square root of the quantity of x plus 9 is equal to the square root of the quantity of 3x plus 11. Now our first step is to isolate the radical expressions in the equation. Since both sides of the equation are just radical expressions, that has been done. The radical expressions are not being multiplied, divided, or have anything being added or subtracted to them. So my first step is going to be to square both sides of my equation to eliminate the radicals. When I do that, I'm left with the equation x plus 9 is equal to 3x plus 11. Since my highest exponent is 1, I have a linear equation which can be solved using inverse operations. Subtracting x from both sides of my equation, I get 9 equals 2x plus 11. Then subtracting 11 from both sides of my equation, I get negative 2 equals 2x. And finally, dividing both sides of the equation by 2 gives me negative 1 is equal to x. Now my third and final step is to plug this value in for x to make sure I don't have any extraneous solutions. When I plug in negative 1 for x, I get the square root of the quantity of negative 1 plus 9 is equal to the square root of the quantity of 3 times negative 1 plus 11. Simplifying underneath the radical on the left-hand side, I get the square root of 8. Simplifying on the right-hand side, I need to first multiply 3 by negative 1 to get negative 3, and add 11 to get 8. So I get the square root of 8 is equal to the square root of 8. That is a true statement, which means that negative 1 is the solution of our equation. Please take a moment to pause this video, record this example in your notes, as well as any questions that you may have. Take care, stay safe, be well, and I'll see you shortly in our Zoom meeting.